Okay, I'm just going to review limits. So we're looking at limits. All right, so right here we're going to evaluate each limit. Okay, so what is the first thing you should always do when checking limits and trying to find limits? Okay, that's why we're not starting with number one. Starting with number 3. All right. So what is the first thing that we should do when finding a limit? You're going to plug the number in to make sure you even have to. Because if you get a number and it doesn't say 0 over 0, you're fine, you're good to go. Right? Or if it doesn't say something over 0. So, you plug this in, we get, you plug 3 in, we get 9 plus 15. Alright, so 9 plus 15, that is going to be 14, no, 24. Alright, plus 6, that is going to be 30. Alright. So already we can see we are going to have 0 over 0. Okay. And then if we plug in 3 down here, we're going to get 9 plus 4, which is going to be 13 plus 1, which is 14. So we have 30 over 14, which is the same as 15 over 7, which right there you can see is, I think I added that wrong. 9 plus 6 is going to be 15 plus 1 is 16. Alright, so actually 15 over 8. Again, all I did there was log in the number, check to see if I had to do anything, and it turns out they gave me a number. So our limit as x equals 3 for this function.
Can I put the right up now?
Sure. Alright, so let's look at number 6. Okay. Actually, first off, let's look at number 2. Right. Number 2 says the limit is x equals 1 of the square root of x minus 1 divided by x minus 1. So if I look at this, first thing that I do is I check the limit is what? Give the 1 to make sure to see if it gives me a number. If it gives me a number, I'm done. If it gives me 0 over 0 or something over 0, I know that it's undefined. So plug in 1, I get 0 over 0. So what does that say? If I have the square root of x minus or plus something, what am I going to do? Correct. So what I'm going to do is I'm going to multiply square root of x minus 1 over x minus 1 times square root of x plus.
Yeah.
So square root of x plus 1 divided by the square root of x plus 1. That's going to just give you, on the top, it's going to give you x minus 1 over x minus 1 times square root of x plus 1. Right? X minus 1 cancels out. So I'm left with 1 . Over square root of x plus 1. So I can plug in my 1 now. I get 1 divided by 1 plus 1, which is 2, so it's going to be 1/2. Now, if you look at number 6, right, number 6 is a little bit different because it has, you know, there's an infinity here. I can't necessarily plug in infinity. So when I have a limit that where x approaches infinity, what do I want to look at? Talk about this is limits approach infinity, we're going to look at what? The end behavior, correct. And the end behavior is also, like, end behavior, like, always infinity and negative infinity is also equal to what? H, and as the second word, we're going to begin with an A. Horizontal asymptotes. So I kind of see this right here. I have rational functions. That's telling me right off the bat that it's going to be something like it's going to be a there's going to be something that has to do with horizontal asymptotes. I also know that since x is approaching infinity, I want to look at the end behaviors, and since our end behaviors is equal to horizontal asymptotes, I want to figure out what my horizontal asymptote is. Now the issue here is that I have two different denominators. So what I'm going to do here is I'm going to take this and to fix my denominators up so everything's the same, I'm going to multiply x divided by x plus 1. We'll multiply that by x minus 1 over x minus 1. And then I'm going to take this and have subtract 4 x minus 1. And I'm going to multiply that by x plus 4. We'll multiply that by, x plus 1 over x plus 1. Because this way, it will give me a common denominator, allow me to make everything into one fraction and look at my horizontal asymptote. So, I distribute this, that's x squared minus x. Then I have negative 4 times x, that's minus 4x. Negative 4 times 1 is into minus 4. And that's all over x squared minus x plus x minus 1. So that gives me is x squared minus 5x minus 4 over x squared minus 1. Now I can look at this and I can figure out that my horizontal asymptote would be what? Why would be 1? They have the same exponents, and then you divide the leading coefficients. So really what you're looking at, you have x squared over x squared, that equals 1. Therefore, I have a horizontal asymptote of 1, which means that limit as x approaches infinity. All right. Questions about that? Now, I repeat, the question similar to that, where x is not equal to infinity, don't just start doing all that work. If it says x approaches any number where it's not like infinity or negative infinity, you always want to just plug the number in and check. Okay? So, there's another one. Let's look at numero 7. Alright? So you have sine of 5x divided by 3x. Now, already this should look familiar to what function? Well,
Oh, wait, are those going to be on the test?
yes.
Cosine.
Tangent will not be. Well, we're going to look at number 9 anyway, so honestly, cosine's not on there, but that one is pretty easy. So number 7, we're looking at this. It says the limit as x approaches 0, sine of 5x divided by 3x. First off, do I know this looks like the limit as x approaches 0 for sine x over x, but this says 5x, It says 3x. What must be true about about what's in the sign and what's in the denominator in order for us to use that trick? It has to be the same. Alright? So I can make this real quickly. I can make this look the same just by taking this and going 5 times sine of 5x divided by 5 times 3 sine, or 5 times 3x. Alright? All I do at that point is I'm going to take the 5 and the 3, that 5/3, I'm going to pull them out. Because I pull those out, I pull the 5 and 3 out, that leaves me with sine 5x divided by 5x. The limit of that is what? 1. So I have 5/3 times 1, which is equal to 5/3. Now, I want you guys to show me your work. But here's the trick. Okay? This function, the limit, whenever x is approaching 0, it's going to be 5/3. This said 7 and 9, the answer would be 7/9. Alright, this said 2 and 7, this would be 2/7. Does that make sense? So all you have to do in order to check your answer on that, after you do all your work, is look, what is this number, what is this number? That's your 5/3, 5 divided by 2. When it approaches 0, yes. When it doesn't approach 0, then don't do that. So, like 8, it says sine of 5x divided by 3x. What we're looking at, the limit as x approaches infinity. X approaching infinity means we need to look at what? And behavior, which means we're looking at what? Horizontal asymptotes. Okay? And when we're trying to determine what a horizontal asymptote is, we're looking at what? Actually, you already said it once. We're trying to determine our horizontal asymptotes, we're looking at what? What specifically are we looking at in the numerator and denominator? The exponents. So what is, now remember, if something's inside the sign, that does not count towards its exponents. So is there anything with an exponent up in the numerator? That means that the highest degree of it is what? Nope.
No,
There is nothing with an exponent, it's 0. There's no variable, there's no x with an exponent up there. And we can't include the sine of 5x. What is the highest degree in the numerator and denominator? 1. So if the degree in the numerator is less than the degree in the denominator, is equal to 0. So the limit as x equals to 0, or as x equals to that is 0. Yeah.
There is no limit, there's no exponent stop. How do it higher than 5?
This is, if something is signed parentheses, that is you don't even consider that. You don't, it belongs to sign. It doesn't get, think of it this way. That, whatever's inside that sign, that belongs, it has no rights to anything outside of those rights. So it just belongs to, sign of X controls it. So it doesn't really affect it. Right? Huh? Yes. Let me see. You want to one? It's more important. Those who review. Alright, so now guys, how much more time is this? Look at this. The limit as x approaches 0 of sine of 4x divided by cosine 5x. Looks hard if you aren't used to the cosine until you realize that if I plug 0 in, I get sine of 0, which is equal to 0. And I get cosine of 0, which is equal to 1. 0 divided by 1 is 0. Not hard, right? I just plugged 0 in. Sine of 4 times 0 is 0. So I have sine of 0, which is 0. Then I have cosine of 5 times 0, or 5 times 0 is 0. Cosine of 0 is 1. So I have 0 divided by 1, which is 0. Alright?
Notice the music on that.
Yeah, this is used when they. Alright. This one looks challenging, right?
Oh, I don't know.
Until you realize, huh? We did do one like that, and we also noticed that unlike this one, we're not doing this one, but unlike this one, this is the same as the denominator, so it's a little bit easy off that too much of this manipulation. Alright, remember, we said sine, if you have sine, the limit as x approaches 0 of sine of monkey divided by monkey, what is this going to be equal to? 1 every time. Alright? Doesn't matter what's in the parentheses, as long as what's in the parentheses is the same as down and bottom.
It'll say 0. Not that.
Huh?
Oh,
It,
what's that say?
yeah, it says pi over 2, but it's, the reason being, it's the same thing. The only reason it's different is because it's, they have the next. Alright. 13. So the limit as x approaches 0. Okay? First thing that you want to do is you check to see that this does indeed, when I plug it in, it gives me 0 with 0. Alright? Or at least something over 0. So, what I'm going to do, alright? The first thing that I'm going to do, I see that things can cancel out, first of all, if I break stuff up. So we have properties of limits. Okay? So what I'm going to do is I'm going to take this, I'm going to rewrite that as the limit as x approaches 0 of 4x squared over x squared plus 3x sine x over x squared. Okay? And really, there should be like, I should write another limit right there. Alright? I'm doing correct proper notation. So what I see is this.
How do you put it like that?
Because I can. It's properties of limits. It says this limit is equal to the same thing as if I do this limit plus the limit of this. Alright? So the properties of limits, the summing difference property of limits. Alright? So this x squared cancels out with that x squared. This x cancels out with that x squared. So that's one of those x's. So what I really have is the limit as x approaches 0 of 4 plus the limit as x approaches 0 of 3 sine x over x. Well, the limit as x approaches 0 of 4 is 4, because it's constant, plus the limit of this 3 sine x over x as x approaches 0, that's just sine x over x, but it's being multiplied by 3, so it's going to be 3 times the limit of that, which is 1. So 3 times 1 is 3, so it equals 7. Questions about that? Okay, number 15 looks challenging too. You realize that it says x approaches positive or negative infinity. So that means that we're looking at what? And behaviors which are the same as horizontal asymptotes, which means I look at the exponents in the numerator and denominator side the highest is 3, the highest on here is 4, so that tells me that my horizontal asymptote is what?
I think 0.
0. Now I'm done. These are probably guaranteed to have 2 questions exactly like this on the AP test. Alright, now you look at number 17, it says the limit as x approaches -4 from the left, alright, from the left of -1 as x, or -1 over x plus 4 plus 3. Okay? So, now this takes a little bit of intuition here, guys. So what you have to do here is this. I'm going towards -4, so I'm at -4 right here. -5 over here, -3 over here. I'm coming from the left. So what number is just, what number is just right here? Right? So, if I have this right here, right, I would plug it in for x. Because what I'm doing is I'm saying, I know if I plug -4 in, it's going to give me something over 0. Alright? So what I'm doing here is I'm taking this, and I'm going to plug this in here, and I'm going to get -1 divided by -4.001 plus 4. Plus 3 really does not matter, so I'm not even going to word, but plus 3 does not matter. It's not going to make a difference. Okay? So I look at this, I have -1 divided by -4.001 plus 4. That's going to give me -0.001. Okay?
Why do you make that, sir?
Why do I make x this? Because I'm coming from the left, so as x approaches -4 from the left, alright, I'm getting very close to -4. This side is -4.0001, so remember that's just a little bit more negative. This side would be like -3.9999. Alright, so I'm choosing a number very close. You can calculate you at 3 decimal places, so I'm going 3 decimal places. This right here, is this going to be positive? Divided by -1 by -0.001, it will be positive negative. Positive. So that's a negative divided by a negative. Therefore, my answer is infinity. If I do that, that's going to be positive 1,000. If I do another one, it's going to be positive 10,000. Right? So these ones, all you do, choose a number very close to whatever side you come from. So if this side is the left, this side is the left. Do this. Right? If it's positive, it's positive. If it's negative, it's negative. Okay? Again, this one's saying you have a piecewise function. Not really an piecewise function, and we want to figure out what the limit is. So all I'm going to do now, in order for the limit to exist, what must be true? In order for the overall limit, what must be true about the right side limit and the left side? So they have to equal each other. So this is my left side, this is my right side. So in order for this limit to exist, they must be equal. So all I'm going to do is I'm going to figure out what my left side limit is. I'm going to plug 1 in. 1 squared is 1. Alright, so limit as x approaches 1 from the right, left of x equals 1. Limit as x approaches 1 from the left of x. Oh, that was the mess. So as it approaches from the right, I plug 1 in. 3 minus 2 times 1. 2 times 1 is 2. 3 minus 2 is 1. Are those minutes equal?
So that's equal one or minus one?
Equal to 1.
Okay, yeah.
They're equal, so that means that the overall limit is equal to 1. Okay? If I had 3, which one would be my right side limit?
Which one's right side at the top?
Is in the bottom always the right side.
To the bottom.
This would be my right side limit, this would be my left side limit. Do I compare what's happening with the function values at 0? No, unless I'm talking about continuity, no. So I'm just trying to figure out what's the left-hand side and right-hand side approaching. If it's the same thing, that's good. There's your limit. If it's not the same thing, what's happening? The limit, what does exist? Okay? So the thing is, I mean, you guys don't necessarily need to write all this down. We're just going over this because, I mean, you're not going to, necessarily get to use it. Okay, 21, I'm not going to go over this exact problem, but to find the end behavior model, right, so if you have a 3x to the 5th minus 2x squared plus 7 divided by 2x cubed plus 4, alright? So, first of all, you only look at the, so there's no horizontal axis, but it's asking about end behavior. So the 3x to the 5th over 2x cubed, well, that all comes out with those, so I've got the 3x squared over 2. Alright, so my end behavior model will be 3x squared over 2. Now to figure out this, alright, I would just take, first of all, you can just take positive thing and think about this. If I square a positive number, multiply it by a positive number, actually no, not even no. This is a quadratic, right? So this is the same as saying that's equal to 3 halves x squared. I know that like a quadratic function with a positive coefficient is going to look like this. So what's the limit as x approaches positive? Negative infinity. As x approaches negative infinity, positive infinity again. Okay. We talked about this right here. Alright. So for instance on this one, it asks, where is f of x discontinuous? Well, find discontinuity. I just figure out what makes my numerator or my denominator 0. So what makes this denominator 0? 3 times 1 equals 0. So where is f of x discontinuous? X equals 0. So then what I have to do, I have to find the extended function for g of x. Well, how do I do that? The first thing I need to do is find the limit as x approaches 0 for this function. So that gives me the limit as x approaches 0. I want to take some shortcuts here. Obviously, well, actually, I don't even take any shortcuts. Sin x divided by 3x, I can pull that 3 out. So I have 1/3 times sin x over x. Do 1/3. Okay, so that tells me that my extended function there will be f of x is equal to sin of x over 3x. When x is not equal to 0, and 1/3 of x is 0. Make sense? Okay. These ones right here, guys, you just have, this is what I said. If you need me to double check that you type the answer correct into your calculator, I will. Alright. Now, to do this, like what you do is if you have your calculator, you just type it in your calculator, and if you're looking at as x approaches 4, alright, what you did, I set you guys' calculators up. is you need to just look at the table and it'll tell you, you can see which number came total. Alright, because you're estimating which one. The 3 decimal places. So, on these ones, it says x approaching negative infinity or positive infinity, you can zoom out. So the first one says y equals, says 2x cubed, then 2x cubed, and then minus 13x squared plus 19x. And then plus 4. And that's divided by 4 minus x. That. First of all, it's going to graph it. Now, I'm not even going to really look at the graph. What I'm concerned about, I'm going to look at my table. So let me do this. So I changed all you guys' calculations to big float 3 digits. So it's going to balance to what we want now. Now we're going to second table set. Your guys should all be set up with this. Alright? The table should already be set up to jump by 0.001. I want to look at, I believe it said x equals 9. So, after your table is set to 0.001, it says as x approaches 4, so I'm going to type in a 4 there. So you don't want to start my table at 4. I don't have to like scroll down 4,000 times. I turn 4 and I hit second table, and I go here and I look, and obviously that this limit would be 1. What is it getting close to?
11.
11 or negative 11?
Negative.
Negative 11. You all see that? Negative 0.03, 0.02, 0.01. Obviously, next logical step would be 0.00 to negative 11. All right. That'd be negative 11. Now this one. You can do this again. You have the absolute value of 2x. So you just go to the calculator. Y equals parentheses that absolute value of the absolute value to x. And outside the absolute value is plus 3 divided by parentheses x minus 1. I'm going to go back and say that I want my limit to be negative infinity. So what I'm going to do, first of all, I'm going to graph this.
Divided by what?
X minus 1. So what I'm going to do is this. And the nice easy way to do this is it says that x approaches negative infinity. I'm just going to go to my table on my second window. I'm going to decide, okay, negative infinity. I'm going to choose a big number, or a very, very small number. So I'm going to say let's choose negative 10,000. Alright, second graph. Okay, what is my limit? My limit is negative 2. So that would be the answer for this. This one right here, I mean, not going to go over this, but it's pretty self-explanatory. You graph it. You should be able to, first of all, when you're looking at as x approaches negative infinity or infinity, you're looking at what? What did you say? And behavior and horizontal asymptotes. These are just horizontal asymptotes. This should be easy enough to look at your graphing calculator and figure out. In fact, I think it's even easier. Like, the first thing that I would do here is just plug 0 in. And then on these ones, you just have to move your graphing calculator, see what's up. Say all horizontal asymptotes. You can get the vertical asymptotes from the calculator. You can get the horizontal axis just by looking at the end of it here, right? So that's a pretty simple problem.
How do you get the vertical ones to the horizontal?
Here's one right here. So this